In this question part, a new fence is constructed as shown on the diagram. We are told that C is due west of B, that AC is 800 meters, and that the bearing of B from A is 195 degrees. In the first part of the question, we have to find the size of angle ABC. We'll work with the information that the bearing of B from A is 195 degrees. Let's draw this angle on the diagram. We are looking for the bearing of B from A, so we can imagine that to start with, we are standing at A and facing the north. Then to find the bearing of B from A, we'll turn clockwise until we are facing B. Therefore, the turn that we make and the angle that we get can be drawn like this. The angle here is 195 degrees. To work further, let's draw the following triangle. In this triangle, we have a right angle here. The smaller angle at the top is 195 minus 180 degrees, so 15 degrees. And the third angle of the triangle is 180 minus 90 minus 15, so 75 degrees. We are looking for this angle, so angle ABC, and since this angle is on a straight line with the 75-degree angle, we can write that it is equal to 180 degrees minus 75 degrees, so 105 degrees. Note that there are other correct ways to reach this solution. In the second part of the question, we have to find the length of the new fence. We figured out that angle ABC is 105 degrees. The key connection to make here is that this angle is actually angle DAE that we found in question part D, and that is equal to 0.720 radian. In our next step, we'll work with these two angles, and since one is in radians and the other one is in degrees, I will first make a conversion so both angles have the same unit. Let's convert DAE from radians to degrees by using the calculator. To convert from radians to degrees, we'll take 0.72, multiply it by 180 degrees, and then divide by pi, which I will enter by pressing second and then this button here. So we get that DAE is about 41.2529 degrees. Here I will use 41.25 degrees. Rounding to 4 significant figures should still give us enough accuracy in our upcoming calculations. So now, in triangle ABC, we have the 800 meters side and the angle opposite this side, and we also have angle CAB, and we are looking for the side opposite this angle. Since we have one side and two angles, which actually means that we have three angles, and we are looking for an unknown side in the triangle, we'll use the sine rule from section 3.2 of the formula booklet. Let's substitute. Side A is the fence, which I will label as BC. This is divided by the sine of the opposite angle, so sine 41.25. On the right-hand side, B is 800 meters, and this is divided by sine 105 degrees. Let's use our calculator to find the length of BC. We have an equation that has just one solution, so it makes sense to use the numerical solver. However, first, I will make sure that our angle setting is in degrees. To do so, I will press Mode and scroll down to the fourth line. Here, I will move over to degree and press Enter. Then to get to the solver, I will press Math, the up arrow, and Enter again. I will clear box E1 and enter the left-hand side of the equation. I will insert a fraction by pressing alpha, y, and Enter. BC is our unknown, so for this I will use x, and in the denominator type sine 41.25 and then close the bracket. Then I will move down to box E2 and clear this box as well. Here once again I will enter a fraction, put 800 in the numerator, and then sine 105 in the denominator. Now I will choose OK, so graph, and then press graph again to get the solution. We have to round our answer to 3 significant figures, and since the third significant figure is 6 and the fourth significant figure is 0, we'll leave 6 as it is and write at BC, so the fence is 546 meters long. Let's see 2 exam-taking tips that can help you succeed on similar questions. The first one is that when a diagram is given in a question, feel free to draw and write on this diagram, because doing so might help you better visualize the situation. The second tip is that when you're using your calculator to work with trigonometric expressions, make sure that the angle setting is in the correct unit. Having your angle in the wrong setting can easily mess up most of your calculations.